And good morning, fourth grade math masters of room 502, the finest room at all of Hamilton TK8, in my opinion. Today you'll be taking the end of module assessment task, module 3. Okay, first thing you need to do is put your name on the test. You're going to be working on this test all the way until just about PE time. The only thing you can do after this test is read a book, okay? So here we go. It is, what's the date tomorrow? 02/13/2020. Okay, name and date, please. Do it right now. Name, date. Let's turn the page. And we're going to start with our math, okay? Let's read question number 1 and see where we're at there. We can zoom in a little bit maybe. I think that's about as good as we're going to get. So, underline with me. Take these notes. I'll give you credit if you just take some notes for me. What is the greatest multiple of 7 that is less than 60? So, multiple of 7 less than 60. Remember what multiples are. It's been a while since we've really discussed them. But for example, 7 times 1 is 7. Is that going to be the greatest multiple of 7 that is less than 60? I don't think so. Let's try 7 times 2. Do you think there's one greater than 14 but less than 16? Because we're looking for the greatest multiple of 7 that is less than 60. Let's try 7 times 3 equals 21. You continue on until you get past 60, but you want to be less than 60, all right? Over here, number 2, what it's asking us to do on number 2, right here, is identify each number as prime or composite, then list all of its factors. And for this one, and I think for the others as well, I better zoom in a little bit, get a bit of better picture of what's going on here. There we go. All right. So, just feel like it's just going to mark this so I know where to stay in between. There we go. Prime or composite. Remember, a prime number only has 2 divisors, or numbers that can be divided into, 1 and itself. So naturally 3 would be prime. Because it's only 2 factors are divisors, but we go with factors 2 are 1 and 3. That's it. Nothing else multiplied by another number equals 3 except 1 times 3. Let's look at 6. 6 is an even number, so I know it's composite. And then we can start listing some of its factors. 1 times 6 equals 6, and also 2 times 3 equals 6. I think that's it. Do the rest for 15, 24, and 29. All right. Number 3, it says, use any place value strategy to divide. Okay, let's think about a place value strategy. Let's set this up. What could we use? Dividing by 9 is a pretty big number, but I think we could do this with a place value chart, couldn't we? Nah, it might be a little too confusing. Mr. Leggett's thinking about it. What should we do? Should we do a place value chart? Not asking us to do the standard algorithm, right? We got to use a place value strategy. So let's think about it. You can tell Mr. Leggett's getting the teacher's edition to see which one they recommend. I'm a little stumped. Okay, we're going to use unit form. So, write this down. 36 hundredths divide it by 9 equals blank hundreds. Okay, so what number is going to be right here? So you're going to write a number there and a number there. Just think about 36 divided by 9, or 9 times what equals 36, and you should be able to get it. Let's go to B. It says 96 pencils come in a box. That we do know. So I've underlined and circled the number. If 4 teachers share 3 boxes equally, so I have 4 teachers, 3 boxes equally, how many pencils does each teacher receive? Okay, let's think about this. How are we going to figure this out? Well, we know we have 3 boxes and 96 pencils each. So that's the first thing we're going to have to do, right? So what you're going to need to do is figure out the number of pencils. 96, 3 to a box, you're going to have to go 96 times 3. Okay, and figure that out. Once you get that, you'll realize that you have to figure out, do a little dividing, because we're going to take all those pencils and divide them among 1, 2, 3, and 4 teachers. We know that this total amount here is, bracket it, 3 times 96. What we don't know is how much each of those teachers will receive. And I'm going to put a P for pencils. And I'll even put a question mark underneath that to show we don't know what that is. Okay? Now we've got to figure that out. How are we going to do that? We're going to divide. There's a couple of ways we can divide. And remember, I know we've been doing a lot of multiplication, but division's the opposite of multiplication. So we're going to make an area model, not another area model. Right? Going to break it right there. So we have 4 teachers. And you're going to put the number of pencils here and here. We'll see what the answer is. Okay. Now we're going to go to a standard algorithm. And we're going to have 4 is our divisor, and it's dividing this number here. Okay. So this number that you calculate here is going to be our dividend over here. So go ahead and take those notes. Remember, pause if you need to. Okay. Let's turn the page. Excuse me. All right, here's our 477 divided by 3. It says solve by drawing place value disk. So this one gives us some specific instructions to solve by drawing place value disk. So let's go ahead and do our disk. One, two, three, 4 lines, 1 across, ones, tens, hundreds. What's our first number? 427. 4 hundreds, 2 tens, and 7 ones. All right. Now, you're going to divide this in 3, and I'm going to go ahead and do it this way. Make some boundaries there, and you go for it. Remember how we do this? I'll do the hundreds. 1, 2, 3, and we take our extra. Remember, we go over here, and you're going to put you're going to have to put 10 right there, because 10 hundreds, 10 tens equal 1 100. Okay, figure that out. And what we're going to do is you're going to write 427 divided by 3 equals something. I know a lot of you are chomping at the bit. You want to get going on this, but please be patient and take all these notes because they will certainly help you do well on the test, okay? So take all those notes. Let's go over here to solve numerically, okay? That's using the standard algorithm. Right there we are. So we're doing 427 divided by 3. It's been a while since we've done multiplication, so remember 3 times 1 is 3, and then we subtract, right? Then we check using multiplication. So I'm going to put this over here as a reminder to show you to check using multiplication, okay? Let's continue on to 5. Use any place strategy to multiply or divide. That's what we're doing right here. So I'm going to squiggly line that. And here we go. Let's go ahead and just do the standard algorithm, okay? 3 into 5,316. Remember, you're not solving. We're just taking notes right now, okay? We're just taking notes. So I know only one 3 can fit in here, so I'm going to put 3 times 1 is 3, and then we'll start subtracting, then we'll start dividing. Let's go over here to this problem. Okay, we have 3,809, and it's being divided by 5. Remember what happens here. We can't go 3 cannot be divided by 5, or in this case, it's 3,000, but we can't squeeze anything in there, so we're going to put an X on top. 5 times 7 is 35, and then we subtract. Remember, 8 minus 5 is 3. 3 minus 3 is 0. We don't even need to put that 0 down. And then remember, we drop the 0 down here and continue dividing. Let's head on down to our multiplication right here. Okay, so here we go. 29 times 56. We could use an area model, right? So we have 29 times 56. You don't have to do the area model. I think it helps. But you can go right to the standard algorithm if you so desire, if you like to do that, if you're comfortable with that. I know a few of you are. 56 times 29. Okay? Going to go over here to 17 times 43. We'll start off with an area model. And it's 17, 10, and 7 times 43. And to refresh your memory, where we go 10 or 7 times 40, 7 times 4 is 28. Because we're multiplying by tens, we have the 0. Remember, that's how we set this all up and how we do it. Let's set up the vertical, and we'll do 43 times 17. Okay? And pause whenever you need that if I'm going too fast. Continue on. Alrighty, it says right here, right there, we got it all. Solve using a model or equation, show your work, and write your answer as a statement. So we're writing, read, draw, write. What we have going on is a new grocery store is opening next week. Going to find out that the store's rectangular floor is 42 meters long and 32 meters wide, 42, 39. It says, how many square meters of flooring do they need? Use estimation to assess the reasonableness of your answer. So a lot going on here. Let's make an area model. And we're going to multiply 42 by 39. Or 39 by 42. So I'm going to put 39, 42. We're also going to use the standard algorithm. 42 times 39. Remember, we're not finishing this. I know you want to, but we're not. And then we're going to estimate something times something equals our squiggly line is going to be close to our answer here. Then we write, they need meters of flooring. And I know I'm going pretty fast, so that's why you can pause and set that all up. Seriously set this up. It's going to be way too much to do, okay, if you don't have the notes. So pause there if you need to get it all down. Zoom out a little bit. That was zooming in, Mr. Leggett. Doing things backwards. All right, there we go. So pause if you need to. Let's go down here. Excuse me. The store ordered small posters and large posters to promote their opening. Okay, 12 times as many small posters were ordered as large posters. So 12 times as many. I'm going to circle that phrase. If there were 48 large posters, and I'll circle 48, how many more small posters were ordered than large posters? So we have 48 large posters, but there were 12 times as many small posters ordered. So let's just kind of do a tape diagram so we really understand this, okay? Large and small. So write that, large and small. I know there was only 48 large posters. So that's going to symbol 48. There were 12 times as many small posters. So there's 148, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's 148. So what do we need to do to figure this out? Well, we have to multiply. So let's set up, go ahead and pause this if you need to. Let's set up an area model. And 12 times as many as 48. So I'm going to do this part, and do 10 and 2 and 40 and 8. So we do 2 times 40, 10 times 40, 2 times 8, 10 times 8. We can set up the standard algorithm. Okay, let's just set that up and do 48 times 12. And then we could say, we still have to figure out how many more. So what we're trying to figure out is not just how many small posters, but how many more. So it's just these 11 times, okay? That's what we're trying to figure out. So what you're going to do is take this answer and subtract 48 from that. Does that make sense? Then you could say the store ordered blank small posters. All right. So you have all that great information there, and go ahead and pause if you need to. Let's go to the next page. Got all that in there. Seriously, I'm giving credit for just taking the notes. So I know you can do that. All right. Let's continue on. Well, I remember this one from last year. Uniforms are sold in packages of 8. The store's 127 employees will each be given 3 uniforms. So 127, 3. How many packages will the store need to order? That's what we're looking at, is packages, okay? We haven't done this in a while. So here we go. Make a tape diagram. So what we know is that there's 8 uniforms in a packet, right? So we're going to put a line here, 8. We know that the 127 employees will get 3 uniforms each. So what this is going to be is 127 times 3, right? So you're going to have to figure that out, what 127 times 3 is. And what's going on here, we don't know. We don't know how many packages they need to order. I bet there's going to be a remainder, though. I remember from last year. So now what you're going to do is take this number, and it's going to be your divisor. And you'll say 8 into this number here. This is going to go over here. Make a little arrow that kind of directs you there, okay? Now, the store needs to order blank packages. Remember, if you do this, you'll get some credit. So go and pause if you need to. Okay, we're going to do, this one's a toughie. And this back page is pretty tough, usually with Eureka. So here we go. There are 3 numbers for the combination to the store's safe. So you got to go to 3 numbers. The first number is 17. The other 2 numbers can be multiplied together to give products of 28. Uh-oh. What are all the possibilities for the other 2 numbers? Write your answer as multiplication equations and then write all of the possible combinations to the safe. So let's just think about it. 28. So think about all the multiples of 28. I'm going to give you a couple here. 28 times 1 equals 28. Okay? So one of the combination possibilities, the first number is 17, right? The second number could be 28 and then 1. Right? Now, we could flip that too, so it could be 17, 1, 28. What's another combination that'll give me 28? Think about it. So, we could do, 28 equals, we got that in there? Yep. So let's do another one. 28 to match that equals 1 times 28. Equals 28. So there we have that 17, 1, 28. So think about this. You're going to have to do a little look at your charts. So we'll have 28 equals blank times blank. Once again, I'm just going to put equals 28 over here. Then you'll have another combination. You have to put in numbers there. 28 equals blank times blank equals 28. And you'll have to put 17, number. I bet it's just going to be a reverse like the first time around. Let's continue on. 28 equals blank times blank equals 28. So our combination will be 17, comma, number. And we'll do one more. 28 equals blank times blank equals 28, and it'd be 17. So think about all the ways you could multiply to get 28. We've done one times 28, but there's 2 other ways to get to 28. You can find one on your multiplication chart, but not on the other. When you're done, give this to Mrs. Chandler. Okay, Mrs. Chandler, and don't read a book. Instead, go on to IXL. That will be your assignment. I forgot we had IXL, so log on to IXL.